Alrighty guys, welcome back to another video on how to solve problem 3.29 out of the Introduction to Electrodynamics by David Griffiths. Here it's asking us to find an approximation formula for potential for this system of four particles, and each particle has their own charge. Let me just draw this out real quick. This is negative 2q, this is 3q. This is negative 2q, and this is just q, and they all are a distance away, a away, and this is our x, and this is our y, and this is our z. So the general potential approximation formula is simply just v approximates over 1 over 4 pi epsilon naught total charge over r plus 1 over 4 pi epsilon naught of the dipole moment dotted with r hat and r squared. So this will be our monopole, mono, and this will be our dipole. So let's just break it down and do each part of the equation step by step. So for the mono, we need to find the total charge of the system, which is Q. So that is simply just adding up all the charges. Let's go clockwise here, plus Q and minus 2Q. And as you can see, this is just simply Q plus Q minus 2Q, which is just 0. Simple, easy. Our monopole is just 0. So, let's move on to our dipole moment. For our dipole section, I should say, we need our dipole moment. And to calculate dipole moment, this is simply just a summation of all the charges times Ri. Ri is just our position, if you will. So we just for example, we just get our first charge, and so we don't get confused here, we can name this charge 1, this charge 2, this charge 3, and this charge 4. So let's start with 1, and we'll go clockwise. Let's do 3q, and again, this is a distance a, right? And this is in the z direction, positive z direction. And so, move on to the second charge. It's negative 2qa in the positive y hat direction, plus our third charge would be qa and the negative z hat direction, right? Negative z. And so our final charge would be in the negative y hat direction, which is just negative 2q a negative y hat. And I just put it there because it doesn't fit on my screen. So, just simplifying this further, our dipole moment is simply just qa z hat minus 2qa y hat plus qa negative z hat. Oops. Actually, to simplify even further here, we could move that negative in front of the z hat. So this will be negative qa z hat. And this last term will just simply just be positive 2qa in the y hat direction. So as you can see here, these two terms cancel, and we're just left with 2qa z hat as our dipole moment. Plugging that into our approximation equation there, we could just do 0 plus 1 over 4 pi epsilon I. Remember, 0 is our monopole, plug in our dipole moment, which is just 2qa z hat dotted with r hat over r squared. And since Griffith wants us to express our answer in spherical coordinates, we know that z hat dotted with z hat is equal to 0. Z hat dotted with r hat equals to cosine theta. So for our final answer, it was simply just the approximate 1 over 4 pi epsilon naught 2qa cosine theta over r squared. Simple as that. Thank you for watching. Leave a like, comment, and subscribe for future videos on this channel.